Pre-algebra, Chapter 9, Section 1, Functions. A function is a relation in which each element of the domain is paired with exactly one element of the range. So your domain being x values, your range being y values. So if I was to make a little, so this is my domain. Here is my range, -2, 3, and 4. I say that 1 goes to -2, 2 goes to 3, 3 goes to 4. One domain is used for only one y value. So your independent variable does not depend on the other variables. For instance, x value is independent. It's time, like time. Time is always independent because we can't change it. So if it's something that we can't change easily or at all, then it's independent. So the dependent variable depends on the variables in the domain. So y values are dependent. And how far we go in a certain amount of time is dependent on that time and how much we have to go on. Vertical line test is a vertical line cannot pass through more than one point at a time. So to tell if it's a function with the vertical line test, we can take our pencil, we can take a line like I have here. Well, that's 1 point, 1 point, 1 point. Looks like a domain, or it looks like a function, or a function so far. So then we go, oh, but we hit 2 points right there. So it fails the vertical line test. So what we can say is that this is not a function because it's using a y value twice. It's using an x value for two y values. So the x value of -3 is used for a y value of 0, and -3 is used for a y value of -2. So this is not a function. If we simply got rid of that point and we kept going, we would see that now we've turned it into a function by being able to get rid of that point. So function rule describes the operation or operations performed on the domain value to get the range value. So a function rule looks like the y equals 2x plus 3. The other there, the f of x, that's how we say f of x, is function notation. It's just another way, a more formal way of writing a function rule. It will take you further than y equals. So f of x equals 2x plus 3 is the same thing. It's just we're saying that this is a function that is in x form. So it has an x in it. That's what that's saying. And this one is just saying y equals. It's very basic. We only use it for a few things. So we're going to start transitioning over to that f of x. So a quick check here of solving. I need to get my x's together. So I subtract 2x. And then I subtract that 2. So that's x equals -5. I need to distribute that 4. So that's 8n plus 8 is equal to, and I'll get those n's together, 8n plus 12. I'm going to get our 8's together, 8 n's, and I'm going to move that 8. So now this is gone. I have 0 equals, that's gone, 4. This is a false statement. I need to take that 3 through, so we get 6b equals 3b minus 12. Subtract that 3b, and we get 3b equals -12. I divide by 3, and I get b equals -4. Solve each inequality graph the solution set on a number line. First, I'm going to add 5 so that I get -5m less than or equal to. So less than or equal to 35. Divide by -5. Change my inequality as soon as I divide by negative. So now I have -7. My number line, I need to have a -7, -8, -6. It's closed off because it's less than or equal to. And because it's less than or equal to, I go to the left. Subtract 2, so I get -24 less than 8y. Divide by 8. So -3 is less than y because I did not multiply or divide by negative. It stays the same direction, but now I'm going to change everything so that y is on the left. Keeps eating the y, so we have -3. So -3, -4, -2, an open dot because it is greater than. We shade to the right. Find the value of x so that the pair of polygons has the same perimeter. Well, perimeter is when we add all of the sides together. So we would have 6x, 7, 8x. So this is 8x. Negative 10 and negative 10 is negative 20. Negative 20 plus 8 is negative 12 equals 1, 2, 3, 4, 5, 6. Equals 6 x's. So I'm going to take my 8x over. So I get negative 12 equals negative 2x divided by negative 2. So I get 6 equals x. So find the value of x. Yep, there we go. How are linear functions used to model proportional relationships? Well, we can determine whether a relation is a function, and we can write a function using function notation. Determine whether each relation is a function and explain. We look back and we go back up to our function. What is a function? A function is find it. A relation in which each element of the domain is paired with exactly one element of the range. So you're only using x one time. We're coming back here. On this first one, we have 54. We have any more 54s? We do have 54. And you see that it's with a different y value. So we can already tell that this is not a function because 54 and they say 56 is used twice. So that domain or x value is used twice, so it cannot be a function. On B, we have 4. Any more 4s? No. 7. Any more 7s? No. 6. Any more 6s? No. Any more 3s? Any more 5s? Any more 2s? So this is a function because each domain value is only used one time and paired with one number. So trying it out. Do we have 1 or 2? There's a 3. Do we have any more? No. Any more 7s? No. Any more 5s? 1s, 2s? So this is a function. So A is a function. And now B. So we have an 8. No more 8s. We have a 3 and we have another 3 and they're with different numbers. So B is not a function since the domain value, since the domain value 3 is used more than once. Determine whether the graph below is a function. Explain your answer. So just going through, if you were to use a straight vertical line, remember the vertical line test, so you can move it over, and it does not appear to hit more than one x value at a time, so the graph of this is, so this graph is a function based off the vertical line test, because it passes through no more than one x value at a time. Again, if we were to make a vertical line, I just moved everything, a vertical line, you can use your pencil, you can use the edge of a piece of paper. So as I move it, I can already see right there at 7. I'm using x at 7 twice. So not a function since the x value of 7 is used twice. Here we have if f of x, remember that function notation, equals 4x minus 7, find the value of each, find each function value. So f of 5, what they're telling you there is instead of f of x, we're going to have that x is equal to 5. And here they have that x is equal to negative 6. So we plug those values in. We get 4 times 5 minus 7. We get an answer of 13. Now we do f of negative 6 is equal to 4. Plug in that negative 6 wherever there was an x. So 4 times negative 6 minus 7, and we get negative 31. So we have f of x is equal to 6x plus 5. Find each value. So this is saying that x equals 7. And the second time x is equal to negative 4. So we rewrite it. F of 7 is equal to 6 times 7 plus 5. And we can go ahead and write the other one out. F of negative 4 is equal to 6 times negative 4 plus 5. So 6 times 7 is 42, plus 5 gives us 47. 6 times negative 4 is negative 24 plus 5, which gives us negative 19. So f of 7 is equal to 47. F of negative 4 is equal to negative 19 in this function. Mariah spent $22.50 downloading songs to her digital music player from an online music store for 90 cents each. Identify the independent and dependent variables and write a function to represent the total cost of any number of songs. Use the function to determine the number of songs that Mariah downloaded. Okay, so going back, Mariah spent $22.50 downloading her song. So $22.50 is what she spent. How did she get to that amount? Well, she paid for each song at 90 cents a piece, but we don't know how many, so that's why we put the X here. So what this tells me is that I have a Y value here of $22.50, or a function of $22.50. So let's see. Use the total cost. Depends on the total number of songs purchased, which is what we talked about. So we get, the way they wrote it is total cost is equal to 9/10 times S, which is what we've done here. I just had it specific to our problem. So you can do a cost of S is equal to 90 cents S. Okay. So you can always go from the more concrete, exactly what we have here, and take it to the more general. But whenever we want to solve it, that 90, I like X, 22.50. We divide by 9/10 on both sides as they did, and that we get X is equal to 25 songs. Okay. So Miss Newman spent $8.82, so she spent that much on postcards that sold for 49 cents each. Because it's 49 cents each, we're using something over and over. So this is the cost. And if we want to make this more general, so the cost, when we use the variable X, is 4,900 times X. So identify the independent and dependent variables. So here, our independent is X, and X stands for each postcard, where X is a postcard. Dependent is Y, where Y, or I shouldn't say Y, I should say C of X, where C of X is total cost. And if we need to find our answer, so that's 4,900X is equal to 882, we divide by 4,900 on both sides, and we get X equals 8 and 8,200 divided by 4,900. We get X equals 18. 18 what? 18 postcards. The two answers here, two sets of answers. We have our answer of 18 postcards, and then we need to say what our independent and dependent variables are. But you can find your independent and dependent variables pretty easy just by setting it up first, so setting up your equation, and then looking at it and going, well, what am I actually doing an operation on? Because whatever I'm doing an operation on is going to be my independent variable here. Whatever's the total and an output is your dependent variable, or your Y. So our vocabulary that we talked about: function, independent variable, dependent variable, vertical line test, function rule, function notation, and how are linear functions used to model proportional relationships. So you can always, whoops, I need to answer that. Coming back up here, it was right here. So it helps us to determine a relation as a function and to write a function using function notation and start changing the way we look at an equation.